Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Universe. Okay, so in the last class we have started the lecture on the chapter pressure. Today in the previous class, introductory class, we have discussed what is thrust and how can we define pressure in terms of thrust. Also, I think we have discussed the unit of pressure, the SI unit of pressure, and we have also defined it. Now, today we will be moving on from there. First of all, so if we just recapitulate it once again, that pressure was basically force by area. Sorry, it's thrust by area, isn't it? Pressure was nothing but thrust by area. So you know that it can be given by this formula like this: pressure equals to thrust by area. So if question is asked that what are the two factors on which the pressure depends, can we say it? Yes, definitely we can say pressure is, as can seen from the formula, is dependent on two factors. One is the thrust and this is the area. So if I consider that we have a constant surface area, the more thrust that we apply, the more the pressure is obtained. So basically pressure and thrust are directly proportional. Whereas if we consider that we are applying the same amount of thrust, then obviously you can see from the mathematical relation that pressure is inversely proportional to area. What does that mean? It means that more the area over which the thrust is being applied, less is the impact, that is less is the pressure. And if we consider less area, a smaller area on which the same thrust is applied, in that case we obtain that impact is more, that is the pressure is more. So definitely we can say that pressure and area are inversely proportional. So this is the basic concept. If you have not understood the concept, if you are not able to just take it, so just pause the video, think of it a little bit, and then again keep on moving. Okay, so now let us move on to the next topic that we will be discussing, that is pressure in fluids. Okay, so in general we see that pressure is equals to thrust by area. Now what is the case with fluids? Just think of the molecular concept of fluids, that fluids are something which can flow, gases and liquids, isn't it? And why they can flow? Because since basically their intermolecular force of attraction is quite low, for gases it's almost negligible, and thus the molecules can easily interchange the space, slide over each other, move away from each other. So definitely liquids and gases can flow. Liquids have a tendency to flow, definitely, but gases, the tendency of flowing in case of gases is far more. In case of gases, the molecules move very fast. Okay, so the tendency to flow is more. Okay, now this is the concept. So both cases of liquids and gases, you can see the molecules when they are kept in a container, when any liquid or gas is kept in a container, what happens? What do you think? The molecules actually move randomly, keep on hitting the walls of the container, and as a result a force is exerted on the walls of the container. This force, when considered on unit area basis, gives the pressure exerted by that gas or that liquid on the walls of the container. Now in case of so if we consider pressure in fluids, so write down the heading pressure in fluids. Okay, pressure in fluids. Now fluids are of two kinds. Anything that can flow is fluid. Okay, so what is fluid? Anything that can flow. Anything that can flow. Anything that can flow is fluid. And this fluid is of two types. Okay, one is the liquid and another is the gas. Now you know that in case of liquids, what happens? In case of liquids, basically the pressure that the molecules exert, okay, they basically exert pressure in all direction except the upper free surface. As you know, in case of liquids, that if you keep the lid of a container open, the liquid does not flow out from that lid, okay, or that opening. So liquids exert pressure in all direction except the top free surface. Okay, so exerts pressure in all directions all directions except the top free surface. Top free surface, okay? And gases, what happens in case of gases? In case of gases, this gas exerts pressure in all directions, virtually all, literally all directions, because the gas molecules can move out in all directions, okay? So definitely the gas molecules hit the walls of the containers, maybe the upper surface or the lower surface or the side surface, okay? So gases exert pressure in all directions, whereas liquid exerts pressure in all directions except the top free surface. So basically this is the difference between liquid and gas, okay? Now when you are considering that what are the factors on which the pressure exerted by a liquid on the bottom surface of the container depends, okay? So specifically we are talking of the fact that the fluid is being kept in a container, and we can consider what is the pressure being exerted by the fluid on the bottom of the container. Now what are the factors? Now there are various factors, okay? So actually if we consider a fluid, actually particular a point in the fluid, say this is a container, okay, and you have a certain fluid, say water, okay, say water. Now this water exerts, if we consider any point in the mass of any in the water, within the water, okay, say I consider a point here, okay. Now here if we consider this point, this red point marked with red color, if we consider this point, the fluid here, okay, exerts pressure in all direction, this direction, okay, this direction, all direction it exerts pressure, this direction, all direction it exerts pressure. And actually this kind of pressure is being exerted at all points also. So two things you have to remember, that if you consider a particular point within that fluid, pressure is exerted in all direction at that point, and also pressure is exerted at all the points within that fluid, mass of the fluid, okay. So considering these facts, now some experimental verification gives us the factors on which the fluid exerted, the pressure exerted, sorry, not the fluid, the pressure exerted by the fluid depends. What are the factors? So it has been seen that this pressure exerted by the fluid is actually dependent on the density of the fluid. So first of all, the first and foremost thing that we need to consider factor is the density of the fluid. If density of the fluid, okay, is more, then definitely the pressure exerted will also be more. Now density is denoted by the letter rho, okay. If this is more, then pressure exerted will also be more, and the vice versa. If this is less, then pressure exerted will also be less, okay. So if you consider that there is a fluid whose density is greater or whose density is higher, then definitely it will exert more force than a fluid which has a lesser density. So this is the main difference, okay, fine. Now the second factor that comes into play is the height of the liquid column. Now what does this mean? Height of liquid column, what does this mean? See, again I am drawing a figure, okay. It has been seen that if I consider a container kept on a level surface or a tabletop like this, okay, and there is a certain fluid, say water, filled up to a certain height in this container, okay, and if two holes are made at two different heights. One hole is made at here, this point, one opening, one exit, and another is this, okay. So if I consider the point 1, which is the point 1, so this is the point 1 and this is the point 2. If I consider point 1, now from the point 1, the height of the liquid surface from the free surface, actually height of depth of this point number 1 from the free surface of the liquid is more than the height of the liquid above the point 2, isn't it? The liquid height of the liquid column above the point 2 is less in comparison to the height of the liquid column above the point 1. Now it has been seen that from these two exit points, two holes, what happens? Water comes out with a greater pressure from the point number 1. So here the water suppose falls like this, okay, we consider this ground, and from the point 2 the water is seen to be falling like this, okay. So what happens basically, it is actually seen that the lesser the depth at which the exit point is present or the hole is present, from that point water comes with less pressure, and more deep the point the hole is made, the higher pressure is being seen from the outflow of the water. So this is the second factor. So we can consider that more the height of the liquid column, okay, more the height of the liquid column, definitely pressure exerted will be more, and less is the height of the liquid column, pressure exerted will also be less. So this is the second factor. And the third factor that actually is dependent on is the acceleration due to gravity. Although you can consider that on the earth's surface, majority of the places the acceleration due to gravity is constant, but still it can vary, okay. So this also depends upon the acceleration due to gravity. So also it has been seen, more the acceleration due to gravity, more is the pressure exerted, less is the acceleration due to gravity, less is the pressure exerted. So here is also the same case, okay. So if we just combine all these three factors, what happens? We get the mathematical formula for the pressure exerted by a fluid. And what is that formula? Okay, that formula turns out to be something like this, that pressure exerted P is equals to H rho into G. So this is the formula of the pressure exerted by a fluid of a certain height, okay. H rho G, density, depth and acceleration due to gravity. So these are the three factors, okay, fine. So now you can easily calculate the pressure exerted, okay. Now if I consider another thing, if I consider that here atmosphere is already present, so atmosphere also exerts some kind of pressure on any free surface, isn't it? So here on the liquid surface above the free surface, the atmosphere also exerts some pressure, isn't it? Here atmosphere exerts some pressure. So if I consider the atmospheric pressure to be P naught, then, and if then we try to determine the total pressure total pressure exerted at the bottom of the container, okay. If I just consider that this height H, we have taken this height H as the height of the liquid column, okay, from the bottom of the container, okay. In that case P equals to H rho is the pressure exerted by the fluid only at the bottom of the container, and if we consider the atmospheric pressure to be P naught, then the formula that we get is the total pressure P net is equals to P naught plus H rho G. So this is the formula, total pressure exerted by the fluid on the bottom of the container if the column height of the liquid column is H, okay. Thus you can easily calculate the pressure exerted. Now next that we come is there are certain laws regarding the liquid pressure. What are the laws? Let us just quickly go through. There are certain laws regarding the liquid pressure. So laws of liquid pressure. So what are the laws? These are very simple or basic points, just you have to remember it. First thing is that inside the liquid the pressure increases with the increase in depth from the free surface. Obviously we can understand this from the formula, more the depth, more is the pressure. So this has been just written or expressed in a statement form, okay. Second factor that comes is that in a stationary fluid or stationary liquid, pressure is same at all points in a horizontal surface. This is very important point. For a stationary fluid, I think you can understand what is stationary, which is not flowing. For a stationary fluid, say if this fluid is not flowing and suppose the fluid is not coming out through these holes, the holes are not present, the holes are certainly closed, okay. If I consider this case, okay, the holes are closed, then definitely this is not a fluid which is flowing. Now if I consider any particular point, say I consider the point here, if I consider a point, this point, okay, this point. Now if I consider this point, at this point what happens, it is seen that the pressure is same at all the points Okay, so if I consider another point here, they are basically at the same horizontal level. Now it has been seen that these points, the pressure at these 2 points are same. Why? Because they are lying on the same horizontal plane. And if we take other points also on that plane, the pressure exerted will be found out to be same. Okay. And third point says that pressure is same in all directions about the point inside the liquid. If we consider this very point, then the pressure exerted at this point in all directions will be same. I have discussed it also in the previous part. Like this pressure will be exerted in all the directions and the value of the pressure will be same. Okay. Next, what is the point? Pressure is same at the same depth is different in different liquids. Why? Because it depends on the density of the liquid. So the density of the liquid changes. Then obviously for 2 liquids having filled in similar containers up to the same height, and if we consider 2 points in those 2 different liquid containers at the same height, the pressure exerted will be different because the density of the liquids are different. So this is the next point, and the last one is the pressure. If the liquid actually seeks its own level. What does this mean? Liquid seeks its own level. What does it mean? If we just remember that we have read something called hydrostatic paradox. Okay, so it is seen that I am just drawing it. It will be easier for me to elaborately demonstrate the point. Okay, if I draw it out. So consider a pipe like this, and there are different kinds of vessels. Okay, one vessel is this like, one vessel is this like. Okay, one is straight like this. Okay, and one is horizontal like this. Okay, fine. Now what happens if water is being flowing through this bottom part, common part? It is seen that in all the containers the water rises up to the same vertical height. Okay, so if I consider this to be the horizontal level, then this height will be all same. Okay, so this is the what it says, that liquid seeks its own level. Okay, so with that we come to the end of this class. In the next class we will be discussing some of the applications of liquid pressure. Till then, please do study well. If you have any query, mention in the comment box. We will be happy to solve your problem. Thank you. Goodbye.